Calculating heading, fuel consumption, and time en route having the true airspeed. Looking at this problem, they give us the wind, distance, true course, true airspeed, and fuel consumption. And they just want to know how much fuel and how long it's going to take us to get there. So notice we're given the true airspeed, which means we don't have to calculate it. We're given the wind, which is coming from 175 degrees true course at 20 knots. The wind is usually reported in true degrees and not magnetic. And the degrees means where the wind is coming from. So the wind is coming from 175. In order to calculate the ground speed, we need to calculate our wind component first. So we take the wind direction and speed, then we took our true course. After that, we're going to utilize our true airspeed. So grab your E6B and set the center of the window to 150 knots. It is easier to use this as the center. Then rotate the E6B to where the wind is coming from. In this case, 175 degrees. Because the wind is 20 knots, let's put a mark on the 170 knots. So now, let's rotate the window to our true course of 75 degrees. Now, we slide down the window and put the mark we had, the red dot, on the true airspeed, which is given to us of 80 knots. Notice that the mark says we need to correct about 12 degrees to the right in order to maintain a ground track of 75 degrees. And also notice the center of the hole, the window is on 81, which means our ground speed is 81 knots. Pretty much we have 1 knot tailwind. With this information, now we can calculate our time en route. If in 60 minutes we travel 81 nautical miles, how many minutes will it take to travel 135 miles? We multiply 60 times 135, and then we divide it by 81. And we get 100 minutes, which is the same as 1 hour and 40 minutes. Now let's figure out how much fuel we're going to use. If in 81 nautical miles, which is the distance we cover in 1 hour, we burn 105 pounds, how much fuel will we use in 135 nautical miles? We multiply 105 pounds times 135 nautical miles, and we divide it by 81. And we get 175 pounds. Now, if we look at the original question, we can see the correct answer is letter C. So far, so good. Now let's look at a more complicated problem. This problem says an airplane departs an airport under the following conditions. We're given airport elevation, cruising altitude, rate of climb, we could be also rate of descent, average true airspeed, true course, average wind velocity, variation, deviation, and average fuel consumption. Don't get anxious for all this information. Let's break it down into smaller pieces. Let's start by figuring out the time, since it's the easiest. The airport has an elevation of 1,000 feet, and we need to climb to 9,500 feet. In other words, we need to climb 8,500 feet. And we are going to climb them at a rate of 500 feet per minute. Doing our formula, to climb 500 feet takes a minute. So how long does it take to climb 8,500 feet? That's simply 8,500 divided by 500, and it gives us 17 minutes. Now that we have found the time, we can figure it out how much fuel we are going to burn. We are told we burn 13 gallons in 1 hour or in 60 minutes. We want to know how much gas we burn in 17 minutes. So we multiply 13 times 17 divided by 60 and give us 3.68 gallons. Now we got 2 of the 4 answered. Now let's figure out our wind correction and ground speed. We need to know where the wind's coming from and what's our true course, which is given to us. And then we're going to use our true airspeed. So clean your E6B from the previous problem, and let's put the hole back in the 150 mark. And rotate it to where the wind's coming from, which is 290 degrees. And since the wind is 20 knots, let's put a mark in the 170. Let's rotate to our desired course, which is 215. And let's slide the window so our red dot falls on the average true airspeed, which is 135 knots. Notice that the red dot falls on the right degree line to the right, which means we need to correct to the right in order to maintain our desired course by 8 degrees. We are told we are given a magnetic variation of 3 degrees west. This magnetic variation can be found in the isogonic lines in your chart. If you remember, east is least. So this is 3 degrees west, so we're going to add 3 degrees. So our magnetic heading should be the 8 degrees correction plus the 3 degrees, which is 11 degrees. But then notice we are given a deviation, which is the correction due to installation of the compass. We need to subtract 2 degrees. So our compass heading is 9 degrees to the right of the true course, which is 224 degrees. Now going back to the E6B, we can determine our ground speed. We have a bit of a headwind coming from the right to the center of the hole of the wind fault on the 128 knot mark. That is our ground speed. So if we travel 128 nautical miles in 60 minutes, how many miles do we travel in 17 minutes? So it's 128 times 17 divided by 60, we get 36.2 nautical miles. Check the math with your calculator. Going back to the original question, we can see the answer is B. There are 2 more problems like this in the FAA test. So I'm going to display them for 10 seconds each. Pause the video and try to determine the answer. Have fun.